So we have seen that for a client to connect to a server, they can go through a number of different routers that forward the request. But how do you identify this client and this server on the internet, really? So any computer that is on the internet is, by definition, identified by an IP address, an internet protocol address. And you know, this IP address would look something like this, for example. This is a private IP address that you can find on your home network. Let's say, for example, this server here has the IP address, for example, let's say it's 10.10.10.1. And let's say this server right here has the IP address 10.10.2. So our client has IP address 2, our server has IP address number 1, and we are going to send a message from the client to the server, and all the routers in between are going to have also a different IP address. That can be 3, 4, 5, 6, 7. Let's say this one is 3, this one is 4, and this one is 5. If I want to send a message from 10.10.10.2 to 10.10.10.1, I'm going to send it not directly to 10.10.10.1, but to the first router, which is going to be my gateway. So this can be your home, a box from your ISP. This can be the outgoing source from your workplace or anything like that. So you are going to send your request to this machine. This machine is going to see you have a request for 10.10.10.1, but I'm not 10.10.10.1, I'm 10.10.10.3, and I know where I should send this request. I'm going to send it right here, and it's going to be forwarded to the server. The server is going to receive this request, and in the request, it's also embedded where it came from, and it came from address 10.10.10.2. So this is very important. When you send a request using an IP, what's called a packet, you are going to send not only where you are going to send your request. So in a packet, you are going to send the destination, but you are also going to send the source. And then you are going to send something that you want to send to the server. The destination is your own IP address, and the source is your own IP address, and the destination is the IP address who you want to send the message to. And so this is very important, and this is going to be used by all the computers on the way to forward your message. Now, so far, we have made a lot of assumptions. We have made mainly the main assumption that all of these machines are on the same network, but that's not always the case. So, for example, your home computers can all be on the same network, which is going to be 192.1 point something. And you can find your home computer, you can find your telephone, you can find your smart TV if you have one, and then you can find your ISP provided box, which connects you to the internet. And what's interesting is that this IP provided box has an IP address for your home, which is going to be most likely 192.68, blah, 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 0.1, but also has an IP address for the internet. And this IP address is provided by your ISP and depends on the country you're in. So let's say, for example, 82.68.0.1, for example. And this is what connects you to the internet. And all the requests you do from any machine inside your home network is going to be made using this IP address. And your box is going to be there to make sure that all the requests you send from a server and it gets back is forwarded to the correct device who made the request in the first place. On exactly the same way, the server on the other end, let's say it's, for example, Google, Facebook, or really any server, is going to receive your requests through a series of different routers. And in the same way, this server has a public IP address, which can be 172.169.0.1, for example. And inside of this bubble, that you cannot see because you can only see the public IP address of Google, Facebook, or anything, but you can bet there is also a lot of servers, and your requests are going to be dispatched on one of these servers. Or if you want to access your photos on Google Drive, your photos can be on any of these servers, which can have a different IP address. Let's say this one has, for example, 10.10.0.1. And internally, this server is going to be, your request is going to be forwarded to one of these servers. So now the question becomes, how do this server know, or this server knows, or all of these server knows where your request should be forwarded when they receive them? And the answer is that each one of these has their own memory of where a request should be sent depending on the IP address, and is going to be called the routing table. So for example, your home box has in its memory a table which says, well, anything that's 192.68.1 point something is going to be going through the interface to the home. And anything else, so else, or something you can see the default, is going to be sent to the internet. So via optic fiber or however you are connected. So this is very important, and it's called the routing table. All right, so what we've seen so far is that all the computers are connected using IP addresses, and they know how to forward requests using routing tables.